You have data landing in Microsoft OneLake, from dynamics, from real-time intelligence, and from virtualized shortcuts. Now you need to figure out how does Snowflake use this data without copying it, breaking governance, or creating yet another pipeline. I'm Eric Tolotti, a partner solution engineer covering all things Microsoft, and in this video we're going to walk through building an Iceberg Lakehouse architecture with Snowflake and OneLake, looking at how it works and how to evaluate if this model fits your data strategy. Every conversation today eventually lands in the same place. How do we use AI across the business? How do we embed intelligence into applications? How do we move from static dashboards to real-time AI-driven decisioning? But AI is only as good as the data you give it. This is the guiding vision of the Snowflake and Microsoft partnership. Microsoft is the central business applications that users interact with all day, key to their daily workflows. Meanwhile, Snowflake sits at the center of the enterprise data estate, where data is engineered, governed, shared, secured, and scaled across clouds and business units. Microsoft focuses on how people and applications interface with intelligence, and Snowflake focuses on how the data is prepared, governed, and delivered to agents. That creates an entirely new kind of pressure on the data layer. It's about building a data foundation that can safely power analytics, applications, and AI all at the same time. And that's why we're building integrations across every layer. Power BI and Snowflake working together for governed analytics, OpenAI running directly against the data in Snowflake, Power Platform and Copilot accessing enterprise data for automation and decisioning, and Cortex agents bringing AI directly to where users are seeking intelligent insights. To support all of this, we need a solid architecture at the core. The data layer must be open, reusable, and trusted across every platform and engine that uses it. And that's where the Iceberg Lakehouse fits into this joint vision. The challenge is making them work together without duplicating your data estate. For years, the default answer was replication. Move the data, sync the data, and store another copy. And with that came higher costs, delayed insights, and fractured security models, and governance that drifted out of alignment. This is exactly what Apache Iceberg was designed to fix. Data becomes open, governed, and directly accessible by Snowflake, by Fabric, and by any engine that speaks the Iceberg standard. Before we jump into the architecture, it's important to clarify. You do not need a multi-platform lakehouse to integrate Snowflake with Azure. There are already proven integration patterns used today. Power BI directly on Snowflake, Data Factory for pipelines, and Copilot or applications calling Snowflake directly through APIs. These approaches are mature, fast to implement, operationally familiar, and for many teams, they remain an excellent choice. Multi-platform interoperability is not a replacement for these patterns, it's an extension of what's possible. It does introduce additional architectural layers, more coordination between platforms, and more governance and operational planning. But what you get in return is long-term flexibility, deeper interoperability, and a more future-proof data foundation. As real-time data, multi-engine access, and cross-platform AI become more central, the Iceberg Lakehouse becomes a powerful architecture to support your future growth. So now we've talked about the why, and now we need to talk about the how. In this sample architecture, we have data landing into OneLake through virtualization, mirroring, real-time intelligence, and pipelines. OneLake makes it easy to collect data from disparate sources in a variety of ways. This forms our raw data lake. When data lands in OneLake, it's stored as Parquet files. What's important is those files automatically receive Delta and Iceberg metadata. This is what allows Fabric engines, which are primarily Delta-based, and Snowflake's Iceberg engine to operate on the same datasets. Now, for Snowflake to read the data in OneLake, we use a feature called catalog linked databases. This leverages the OneLake Iceberg REST catalog APIs to allow Snowflake to access both the Iceberg metadata files and the underlying data files, making the data appear in Snowflake like it would any other database, queryable by both SQL and notebooks. From here, Snowflake can process the data like any other data engineering workload, merging it with data already ingested directly into Snowflake native tables, along with data from Snowflake data sharing. Data is modeled, business logic and metrics are added, and curated datasets with semantic views for both analytics and AI are generated. This curated layer is built using Snowflake's managed Iceberg tables back in OneLake, once again making the data accessible by both Snowflake's Iceberg engines and Fabric's engines. Intelligent Cortex agents are accessible across the Microsoft AI estate, and Power BI can run off of Snowflake across all of its modes. and any downstream Azure services using OneLake can operate on this data. Let's see what this looks like in action. We have data in OneLake. An Azure app registration is set up to enable OAuth access, and this is used to create a catalog integration in Snowflake. The catalog integration is a named account-level Snowflake object that stores information about how your table metadata is organized. In this case, it's telling Snowflake that the OneLake table APIs are the source of truth for the Iceberg data in OneLake. And then an external volume is created. This tells Snowflake the data files are being stored externally. So the catalog integration is for metadata files, and the external volume is for data files. This automatically creates a multi-tenant service principal that needs to be added to Fabric to allow Snowflake access to the data. Now with everything linked up, the catalog linked database can be created in Snowflake. And now the Lakehouse tables in OneLake show up in Snowflake just like any other data object. Once in Snowflake, this raw data is modeled into a gold layer using dynamic tables, enriched by data brought in from Snowflake sharing, and we want this curated database to be written back into Iceberg in OneLake. In Fabric, a connection is created to Snowflake, with the multi-tenant service principal being given access. From the Snowflake UI, under Ingestion and Add Data, OneLake is selected and the relevant connection information is filled in. Iceberg tables are created with the curated gold datasets. And from Fabric, you can see a Snowflake database has been created with the tables inside of it. This makes all of the data available within Fabric. Once the setup is done, additional catalog linked databases and Snowflake managed Iceberg can easily be added as well without repeating the connectivity steps. And there you go, a shared Iceberg Lakehouse that lets Snowflake and OneLake operate on the same data with a unified open foundation. A clean, unified design built for modern analytics and AI. It's a powerful architecture designed for the future. Thanks for watching.